A wonderful breakthrough has occurred. The paradox experiments led to the discovery of an underlying field, which I call a pretonic field, from which all of electromagnetism can be derived. This new version of electromagnetism, which is based on the underlying field, is called New Electromagnetism version 5. Okay, actually, we found two variants of that underlying field. So there's two New Electromagnetism V5 variants that we need to figure out which is the right one. In this video, we're going to show the experimental results of New Electromagnetism V5 compared to the older models. Now, this image on this page right here, this is the Fusion 360 CAD models for all the experiments used in collecting the data for this video. It's just you turn them all on at one time, they superimpose, and it makes a weird looking evil clockwork thing. So I thought it was a neat picture for the opening slide here. What you see here is a punch list we're going to use where we're going to show variant A and variant B. Now, I also put in C, D, and E just kind of as these are things we should consider, but I didn't expect them to go anywhere, and they didn't, but we're still going to show them. So this is our punch list where we're going to compare all the experimental data, and this goes on a lot longer. We'll show it as it goes. But also, this is going to be a long video because we have to go back to the beginning. Okay, and we're going to compare everything to everything, all the experiments we did, and we're going to still compare classical theory, New Electromagnetism version 3, which is version 3 and 4. We'll explain that. Okay, so this is going to be a long video, and hopefully because I have animations in there, it should not be as boring as my normal videos, but this is going to be a long video. So let's get to it. Okay, so the agenda is because we're going to be filling out that punch list I showed you on the previous page. We're going to have to go back in time, and I need to explain to you what these experiments mean in the relevant history of New Electromagnetism, and so we're going to kind of have a chaotic history lesson here of how everything evolved, because we're going to be bouncing back and forward through time as we fill out the list. And we'll be using the physics software. We're going to show you the experimental data, and then at the very end, we're going to show you the next step, because remember, this is part 1. We got a lot more things to look at. We got a lot of disambiguation left to do before we make the final decision on which of the variants, A or B, is going to be version 5 of New Electromagnetism. Okay, so but what about the other theories? You know, people say, well, why don't you compare the experimental results with, let's say, Ken Wheeler's or the Weber equations or these other things? I have a video out there. It's T13. I will have all the links, all the videos I describe in this video in the low bar will be listed, so you can go click on them later. I already reviewed a lot of other theories for comparison. Most of the other theories out there are already just rehashes of classical theory. Most of the competing theories are completely devoid of models. Okay, in other words, I need models, and we'll talk about that in a second. And the remainder of all the other contenders are just plain gibberish. Okay, like for example, I get a lot of people from Ken Wheeler, and I'll let you read this on your own. This is one of the comments. This is about 10 days ago at this point, and this is my response. Okay, and you can read that on your own. You can pause now. But the other thing that, you know, the thing about Ken Wheeler is he talks in very general statements. You know, he'll say that a particular field is an ether modality. Well, that sounds fantastic, but it's saying absolutely nothing. All he is saying is that particular field has something to do with the ether. That's all he is saying, but a fancier word, so. Okay, I need models. There's no way I can take a generalization that the ether has something to do, a field has something to do with the ether. It tells me absolutely nothing. How can I turn that into a voltage or a current or a measurement or a magnetic field intensity? I can't. There's no way. He does not produce any models. Okay, so, and I agree with him. I agree a lot of fields, or all the fields are ether modalities. But I'm going to tell you when we get through all this exactly what the modalities are. Like, for example, gravity is an acceleration of ether. Okay? And inertia is you accelerating relative to the ether. And I will be able to give you numbers that you can measure and take to the bank and build things with. Because if you just, and the other problem is people say, well, these particular models, these things can't be measured, they can't be quantified, like somehow that is some kind of sacrilege to be able to measure something. I'm sorry, if you're saying that your theory cannot be quantified, what you're saying is it affects nothing in our universe. Because if something affects something else, you can measure and quantify that effect. If you say, oh, my theory is not quantifiable, what you're saying is it's a ghost story. It doesn't affect anything in our universe. And I'll leave it at that, because I can go on for hours. And even physicists out there with their quantum entanglement are producing ghost stories. But I'll go on. So for all of this experimental data, we're using the new electromagnetism model of magnets. Okay, again, there'll be a link in the low bar at the end. You can go on and review this. I have a updated release for the new electromagnetism V5 release, and that gives a more updated, it's the same theory, it's just probably a better video than the earlier video I have. And we have to, what we're using for most of the experiments, we have one magnet that's been quantified very precisely. It's 1.26 inches in diameter, 1/8 of an inch thick, and it's 2,790 amps on the edge current. And you can see the edge current because if you put a MagnaView film over it, you can see the edge current is highlighted there. That's what the MagnaView film shows. Okay, I'm the first person to recognize the MagnaView film shows edge currents. It's in my paper, New Magnetism, which came out nearly 20 years ago. Okay, again, that New Magnetism paper, some of the language is a little bit dated, but it's still pertinent. So let's begin our chaotic history of new electromagnetism. In the mid-1990s, I realized that Faraday's law does not explain self-inductance. It explains mutual inductance, and that's what this is. You have two loops of wire, and if you put a changing current in one loop of wire, it'll couple a voltage into the other loop of wire. That's called mutual inductance because it's a mutual coupling between two loops of wire. Self-inductance is a loop of wire that couples to itself. That's self-inductance. Faraday's law does not explain that. You end up with a division by zero and no result. So I did my own experiments. I built this neat little rhombus, and I put a very fine piece of wire right on the inside edge. And by changing the shape of this rhombus, I could develop data that I put into a computer, and it did a computer search to find all the possible physical arrangements of those fragments of wire that could come up with the answer that I was seeing. And the result of that was new induction. And this is the model for new induction. And if you look very closely, it looks just like F equals ma. Don't be confused by the minus sign, because this is the inertial force that reacts to you pushing on a mass. So if you push on a mass and you accelerate a mass with your applied force, you're going to feel a pressure pushing back on your finger that's in the opposite direction to the acceleration. This is the inertial force that's reacting to you trying to push the mass. We engineers use this a lot. Okay, so if you set new induction equal to this, you have the first ever derivation of mass being completely an electromagnetic phenomenon. And if you go into the Foundation Series playlist, I have the link at the end, I go into computing the mass of electrons, protons, and hydrogen atoms. Okay, and in much later video, this I did back in the 1990s, and we're going to go over this a little bit more. But in a trailer video, a recent one, T18, I compute magnetic, using, similar to this, the magnetic moments from Ethereal Mechanics. I compute the magnetic moment of the electron, the muon, and the tau particle. I get exactly the same experimental results that they get, but they don't have a result for the tau. So this is the first ever prediction of ethereal mechanics on the tau particle. And you can go watch this video, see how I did it, and see when they finally are able to measure the tau, see how close my prediction is. And the solution for this is so simple, even a physicist can do it. Screaming ahead to 2007, I used the new induction model in my graduate thesis to compute the inductance of circuit board traces. Here is a printed circuit board trace inductor. Here's my trusty, rusty Agilent LCR meter. And I was able to get
dead on balls accurate.
A lot of the other a lot of the other prior art that I had seen was empirical models where they measured a bunch of things and did some empirical work. The only prior art that was field-based that I could find was a thing called partial inductance. But partial inductance violates vector magnetic potentials. It is not classical theory. You go in my graduate thesis, I go into great detail about partial inductance, and I also show you that partial inductance degrades when you start getting to curved inductors, like this loop inductor here. Okay, and the other beautiful thing about my work, the coup de grace of my work, is that new inductance can give you printed circuit board trace inductances when there's one or when it's sandwiched between two ground planes. So in other words, if you have a ground plane in your printed circuit board and your inductor is next to it, new inductance will give you the dead-on balls accurate answer. If your trace inductance is sandwiched between two copper conductive ground planes, it'll give you the same answer there. Nobody else. There was no other prior art out there for dual ground plane computations. Only me. Okay, and like I said, you get the actual force within the wire. You can see where the force is, what the intensity is, what the direction is at any point within the wires in the copper. Okay, so filling out our punch list here. We have mutual inductance. We have lots of data on mutual inductance. That's what this green means. Classical theory and Maxwell's equation. New Electromagnetism version 3 and the New Electromagnetism version 5, the A and B variants, all give great answers for mutual inductance. Okay, for self-inductance, we have lots of experimental data. I have lots of experimental data. Classical theory gives you division by zero. Version 3, A, and version 5, A and B, give excellent results. Take it to the bank results. Now, I'm going back now to 1997, going back in time, back 10 years back before the graduate thesis. Okay, so, because in the graduate thesis, I was using New Electromagnetism version 3. And you say, well, where's 1 and 2? Well, that's what we're going to talk about. So after I came up with the new induction model, whoops, that's down here, I said, gee, it's pretty cool. It shows that, electromagnetic physics, since it's based on charges, well, that means we should be able to write, and this is a second-order effect, acceleration. Well, there should be zero and first-order effects. The zeroth order of position is position. The first-order derivative of position is velocity, and the second-order derivative of position is acceleration. And, well, Coulomb's law gives us the zero, and I really shouldn't call it a law. Calling our models of nature laws are ridiculous. It's a model, not a law. It's Coulomb's model. We just got to stop calling mathematical equations laws. They're just models. And it's a model because we have this empirical, this value here, this arbitrary constant of relation here. And when we get to New Electromagnetism version 5, all the arbitrary constants of relation go away. Yes. In the rules of acquisition, there should be no arbitrary constants of relation. You can have constants like velocities and things like that and quantity, but you can't have arbitrary constants of relation. And you'll see that these constants, these arbitrary constants, go away when you know what you're doing. So then the question is, well, what are the first order effects? Well, I looked at classical magnetism because that's got velocity. And if you take the Biot-Savart model and fold that into F equals QV cross P, you end up with a point charge version of magnetism that will fit in. Now, I'm not the first person to come up with this. Okay, I mean, I came up with it on my own. I did not know there was previous art that already did this, but I found out later there was. So I can't take credit for inventing it, but whatever. And so this became New Electromagnetism version 1. Now, it's actually version 2, but because version 1, I wrote things without the direction vectors, because this is how you write it in the software. And this is more computationally efficient than this is. And so I wrote it this way because I was doing a lot of software on this stuff, and let's write it the way I'm going to use it. But then later on, I'm like, this might confuse people. So I wrote it in the proper ways using the direction vectors. So this is actually version 2. Okay, so the difference between version 1 and version 2 are really just a format, display format. They're the same model. So I call all of these collectively version 1, but we're really using the version 2 variant when I say version 1. Okay, so that's why kind of version 2 is kind of a throwaway. So I typically use the term version 1. And we don't use version 1 anymore. Okay, but the interesting thing is when I saw new electromagnetism and new induction written this way, it spoke to me. These equations spoke to me. It said I could define matter as a system of charges. Okay, so if you take a hypothetical system of inertialess charges, now I used the term massless charges back then because, and so if you look at my older papers, which, NG PDF, we'll talk about that in a second, I still use the term back then, massless charged particles. That's a misnomer because in chemistry, massless means quantityless. Therefore, massless really means non-existent. Okay, the problem is physics have, I don't know what the right word is, but they have merged the concept of inertia and quantity together, and they've come up with a disaster because it masks some of the wonderful properties of matter. Okay, inertia and quantity in ethereal mechanics are two separate things. Just like we disambiguated weight from mass, we need to disambiguate inertia from mass. Okay, now if you take this system of inertialess charged particles and you put them in orbit about each other, they become, all the forces of electromagnetism, version 1, cancel when they spin at the speed of light. In other words, when the tangential velocity is c. And then it shows that the inertia of the system, what we previously call mass, is a purely electromagnetic effect. The energy of the system is E equals mc squared. The system when the system's in translation, it spins and slows according to the time dilation. And then when its speed surpasses the speed of light, it collapses, which gives us the mechanism whereby black holes form. And it proves, it is exquisitely saying that there has to be a medium. Okay, and this is the beginning of ethereal mechanics. If you want to see more about this, look at the new gravity paper. It's a little bit obsolete. We're going to have new versions of ethereal mechanics. Gravity is going to be is coming out after new electromagnetism version 5 that are going to show you more improved gravity model that explains more of the things that we see, and it fixes some of the problems for this older model. Okay, but if you want to, in the low bar, there's a link for new gravity PDF, ng.pdf. Okay, but there was a problem with this model. The problem with this model is that these things only work if this system is moving up out of the page. But if you take this system and move it off to the right, it disintegrates. And I'm like, well, that can't be. Matter should be able to move in any direction without disintegrating. And I figured, well, gee, if I add one more term to this magnetism equation, then this hypothetical model of matter can move in any direction, and it will still experience time dilation, blah, 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 everything that we would expect matter to do. Okay, and so this became new magnetism. Now, I have 2002 here. I actually think this happened earlier. I think it actually occurred before the millennia, but I haven't had a chance to go back and look at the actual time. Okay, so now once you take this new magnetism and fold it into, you end up with new electromagnetism version 3. Okay, and this is circa 2000-ish. Okay, now version 4 came about during my graduate thesis because I reconciled that, hey, wait a minute, electric fields must store potential energy and magnetic fields must store kinetic energy. And so I ended up expanding the definition of electromagnetism to include potential and kinetic energy effects. Okay, it didn't change these models, it just added energy considerations. Now, I thought I came up with this, but during my graduate thesis research, I read Maxwell's books. I found out he had that in his books, but somehow it got lost over time. I don't know why, but humans seem to reject knowledge over time. I don't know why. Okay, so this is New Electromagnetism version 3. Now, I still call these collectively, whether you're talking about the version 3 or version 4, I still say version 3. Now, the reason why I'm going all into this, you understand why we're up to version 5 already, because I already have a version 4, but it's really the same as version 3. Okay, so if you want to go into more detail of how New Electromagnetism evolved into Ethereal Mechanics, you can go to the EM Foundation series. I have the link for this playlist in the low bar. You can go look at that later. Okay, but as time went on, I didn't want to be able to say to people that might ask, well, how did you come up with this third term of magnetism? I mean, I can't say, well, I inferred it from an insane model of matter. That's not going to work well. Especially since this happened before 2007. Remember, in 2007 is when I finally had the confidence that things were right. So I didn't want to be able to expose my model of matter because it was hypothetical and it had some wrong things. But you'll find over the time, I've improved the model, that we've eliminated a lot of the issue. We're not done yet. We've still got some way to go, but we're getting there. It's on the way to explaining everything. Okay, and so I wanted an alternative, a sane way to justify the new term. And I figured, gee, if you look at the normal magnetic equations, if you take two parallel wires, one with a current in it, and you have a target wire, if I move the target wire to the source wire, I induce a current, in this direction. If I move this target wire away, I induce a current in the upward direction. Well, that's great, but this doesn't tell me what happens if I move the source wire left or right. The source velocity is not considered here. And a lot of people say, oh, yes, it is. You just got to replace the t with the relative velocity, and that fixes the whole problem. You're absolutely right. That's what physicists and engineers have been doing. But unfortunately, why haven't they bothered to put this in the equation? So let's do that. Let's finally do what physicists should have been doing for hundreds of years. Let's update this equation with the velocity of the target minus the velocity of the magnetic field, because that's really what they're talking about. And so if we go back and expand this the same way we did with new magnetism, we end up with 4 terms, strangely enough. Now the question is, well, what is the velocity of the magnetic field? Well, in this case here, definitely the velocity, if Einstein is right, the magnetic field follows the source, which follows the wire, which means following the source. So I should be able to replace the velocity of the magnetic field with the velocity of the source, Vs. Okay, so that leads to a 4-term expression, and we have the 3 terms of new magnetism that came up by inferring from the hypothetical model of matter. But then we have this 4th term, which just destroys everything. Because what this 4th term says is that using this now for traction, if I have 2 parallel wires with current in them, okay, and I use the velocity of the source, which includes the velocity of the current in the wires, okay, this says there should be no attraction between the 2 wires. And if I have current going the opposite direction, so I'm going to have 2 times the repulse. So therefore, we can't use this velocity. Now here's my spoiler here. What I'm about to show you is there's a big contention in magnetic theory over the velocity of the source charges. Okay, in this variation which I'm following, which is my new electromagnetism way of explaining things, the velocity of the source charges include the velocity of the charges in the wire and the velocity of the wire. Okay, and this is going to come out time and time again, is the velocity of the source of the magnetic field is an issue. And I'll say that again. The velocity of the source of the magnetic field is an issue. That means the velocity of a magnet is an issue with classical theory. And what I learned later on, getting into the new electromagnetism, it's actually the velocity of a magnet in a curved path is even worse. That's where all of classical theory breaks down. But we'll talk about that later. Just going to say it again. Keep it in your brain. We're coming back to it. The velocity of the source of the magnetic field is an issue. Okay, so this actually works. If you knock this off, we get back to new magnetism, and we get the right answers for this experiment and the one before it. Okay, so because I can get the right answers for these experiments, and you'll see, because we're going to use this with new magnetism to compute actual experiments on this later, we're going to get the right answers. Okay, but now we still need something to compare our experimental results to classical theory. Well, what we need to do is we're going to still do the same thing, is we're just going to replace the VT, VS in the equation like everybody does, but we're not going to then discombobulate the current. In other words, the velocity of the sources in the wire are not going to be considered part of the velocity of the source. So here we're separating the velocity of the wire from the velocity of the charges, whereas in new electromagnetism, you have to consider all velocities, okay? And that's what separates new electromagnetism from classical theory, because here, this works, but I'll show you it breaks down when we get to some real experiments where the source of the magnetic field is in motion, because this does not account for everything, and this is why it breaks down. Okay, so here we're saying that the velocity of the charges in the wire are independent of the velocity of the wire, and this is going to give us our corrected classical theory. This gives us good results for most things that we're going to do. Okay, but like I said, we're going to show experiments where this breaks down. Okay, so now here's the physics software. Okay, the physics software, I don't know if you can read this thing up here, but we have a one class that computes the interaction for every type of electromagnetic theory I've been trying out. So every variant or classical theory or new electromagnet has a separate file with a class. So when the computations come in, they go to the correct theory for computation. So this little area here, this is part of the loop for computing fragment to fragment EMF effects. So we're going to take what we had before, and you can see this is computing B is KI DL cross R over R squared. So here's where B is computed. It should be DB, but whatever. Here's KI. KI is Km times the source current times the vector DLS cross vector R divided by DD. Now R starts off as the difference between the target position and the source position, and then we compute out D, which is the magnitude of R, and the magnitude square, which is D times D. Since we don't need R anymore for magnitude, we divide R by D to make it a direction vector. So the capital R in this point here is our direction vector here. Okay, so here we got DLS cross, and in my physics software, these M vector 3s, I have overridden the operator. So when two M vector 3s are multiplied with a star, that does the dot product. When two M vector 3s are multiplied with the percent sign, that does a cross product. That way there, it allows me to dictate or transcribe right from equations right to software, and it looks the same, because there you go, VT minus VS cross B, VT minus VS cross B dot DLT, and there's your dot DLT. Okay, so this shows you this is the exact model we're using for classical theory for EMF. Okay, and now we're going to use new because now new electromagnetism computes all the velocities. You notice that the source velocity is all contained here. Okay, so first thing we're going to do here is, because we're going to start turning this into a fragment equation instead of a point charge equation, first thing we want to do is put it into the terms of what I'm going to use quote unquote with air quotes electric field. This is not really an electric field. This is a force per Coulomb field. We arrive at this by dividing both sides of this by QT. And that gives us ET. Okay, this is force per Coulomb field, but it's not a conservative field, so it's not really an electric field, but it does have the same units here. I should probably pick another symbol for this, but whatever. Just remember, this is not an electric field. This is a force per Coulomb field. Okay, and then next we want to substitute charge velocity with current times fragmentary length. Okay, I call differential length of a conductor, I call that a fragment. Okay, and then we end up with our a delta or derivative or differential ET. Okay, and then we want to make this, and then we do this, and we do this. So we end up with this here. Okay, I know I did a lot of steps there, and I didn't explain them, but most of the people that are looking at this aren't going to follow that anyway. The key here is this is our final equation that we're going to put into the physics software. So we bring that down here, and I'll let you pause and look at this. And the only thing extra here is we're considering acceleration, because we have to consider everything. Okay. And this is the same setup, but this is the interaction for new electromagnetism V3. Okay, I'm not showing the equations for V5 yet. Okay, I'm keeping those under wraps until I have a chance to write and copyright the new electromagnetism V5 paper. And then you can read the rest of this on your own. This is how everything else is going to be released to everybody. So we're going to go back now, and we're going to do the parallel wire experiments. Now here, what this blue M means is that we're saying that we believe classical theory gives us the right answer, and because M is our symbol for classical or corrected classical theory. Okay, and so we're saying the blue means we don't have experimental data specifically for this. Instead, we're using the data for M as the data for everybody to compare against. Okay, and so when we do all that comparison, we do all the computation simulate, we all get the same answers. They're identical down to so many decimal places, it doesn't matter. Okay, now let me explain what this means. Target plus means we're moving the target fragment toward the source. Source plus means we're moving the source toward the target fragment. So the pluses means we're moving the wires toward each other. Minus means we're moving the wires away from each other. And this is the voltages that are computed to there's probably more digits of significance here. Up here. Okay, so now if you want to double check me, you can do a simple two-wire approximation for these. If you use an infinite source approximation for the source, you end up with 66 millivolts, whatever. So if you want to put these values in and compute them with some other tool, and I don't mind being proven wrong. I'm human. I make mistakes all the time, but I'm pretty sure these are the correct answers for these. Okay, and for the wire force experiment, if I have two parallel wires with 10,000 amps in them, then we get 49.6 newtons of force pulling them together. And we're going to put that, and we get the same answer. Again, we're saying we could use any one of these because they all agree to the exact same precision, whatever. We're saying because they all give the same answer that we don't have to actually measure this because I don't know where I can find a 10,000 amp source, yada, yada, yada. So now let's do an actual force experiment. Now we're going ahead now to 2017. And 2017 is where the physics software came about because I really needed a simulation software tool and a tool that did, that could show me how everything relates. Because most of the time when you make a mistake in simulation software is you have a dimension incorrectly. And to be able to see everything, make sure the dimensions look right is critical to not wasting time trying to figure out why you're getting weird answers. And so I actually ran this experiment. There's videos on it on the NEMA videos, which is New Electromagnetism Application 7. We were testing out the physics software and a force table. So what you have here is you have a coil of wire that we're going to put 20 amps through. Well, it's actually a 20-turn coil of wire we're going to put 1 amp through. It doesn't really matter. In the simulation, I'm using a 1-turn coil with 20 amps. It all works out the same. The distance from the edge current of this bar magnet or rectangular magnet is 22 millimeters. Okay, and what you have here is this is the apparatus for measuring. What I'm measuring is the force in this direction. Okay, this bar here is suspended by strings, and it's tied over a pulley off the edge of the table to a mass that sits on a weight. This 9.55 grams is how much weight was removed from the force on this string. That worked out that this force on this string was 93.6 millinewtons. Now, when I originally ran this experiment back in 2017, this is before New Electromagnetism version 5. And as you can see, New Electromagnetism version 3 was way off the mark. I mean, it's far enough off that I can say this is not a measurement error. Something was wrong. And the only thing I could come up with back then, because I did not know New Electromagnetism version 5, is that, well, maybe the string stretched, and as it got closer, the force increased. But this is a 2 millimeter, almost a 2 millimeter measurement error. There's no way my eyesight's that bad. Okay, and so I struggled with this for a while, but now that I'm going back and rerunning this, we're seeing New Electromagnetism V5 is actually about 5% more powerful, and this gets us into the realm of this could just be measurement error or instrument error. And so now I'm much more accepting that New Electromagnetism version 5, and this, both variants give the same answer here. Okay, but before we can give the win here to New Electromagnetism version 5, now back up a second. So we're within about 5% error here, but this is 10% error for version 3. Oh, and classical. Okay, classical gives us, they're sitting right on top of each other. That's why you don't see the traces. Okay, but the next experiment, where we have the ring beside the magnet, so that along this plane here, this is in plane with that interface between the green and the red, which is that edge is where the edge current is right there. So we're parallel to the edge current, and we're pulling this magnet in, and we have the string attached to this side going off the table to the weight. We call this the coil beside the magnet test. And we end up with this experimental results. Now, everybody's within 5% here, so you could give it either way on these guys. But the interesting thing here is the critical thing for both this experiment and the previous experiment is there is a difference on these force predictions for both classical, NE3, and the New Electromagnetism version 5. So I'm not going to call either of these experiments one or the other. What we're going to do is, because we have a difference here, this means we can figure out a way to make an experiment that expands these differences to the maximum and repeat that experiment, so we can have a better selection of which theory is correct. And it could also be that neither of these are as accurate as they need to be, and there's a third model out there that we haven't seen yet, or a different model out there, a different variant of New Electromagnetism V5 that we're unaware of as yet. That's fine. So we're going to keep our options open here, and we're not going to call either classical or New Electromagnetism. We're going to run these experiments in better precision, okay, so that we can get a better find out, which one it is for real. So the way we're filling out our punch list here is the magnet above, or the coil above and the coil beside. We're saying experimental data is not that accurate, and we're going to say these are all marginally correct. That's what the M stands for. So we're going to come back to these experiments at a later time. Okay, now going back to 2004, okay, this is before I did my graduate thesis and had real confidence in my New Electromagnetism. And I didn't have, and my graduate work, I gained a lot of skills that I didn't have back here. And so I didn't have the confidence to go diving down deep rabbit holes. I was not the rabbit hole warrior that I am today. Okay. And so I was very hesitant about spending a lot of time on things that I was not sure about. So anyway, in 2004, I came up with an experiment that would distinguish New Electromagnetism from classical theory. Again, we're talking about New Electromagnetism version 3 back then. And it came up with the paradox 2. And people say, well, William, why did you start at 2? Why didn't you start at paradox 1? Because there was a paradox 1. It was a homopolar generator. And I came up with a homopolar generator way to explain this. But unfortunately, back in 1999, my skills were not quite as good. And I did not do the proper engineering on this to find out the results from this experiment were ambiguous. It didn't favor one model over the other. And so this was a failed experiment. I can go on to all the details of why and why and why. There's actually a video on this somewhere that explains this can be done, but in order for the experiment to work, it's got to be scaled up to an unbelievably large scale. And I don't want that. I want a simple experiment that the average school kid can do to show New Electromagnetism over classical theory. That's what I want. I want to be able so everybody can see it and they can do it for themselves. To make this experiment work, it requires me to make a very large scale, and I don't want to go down that road. But maybe we'll go down that road later as a curiosity later. Okay, so now this is the Paradox 2 experiment from 2004. Okay, and what it is two magnets rotating around a copper ring. This copper ring here is stationary. Okay, this copper ring is it may look like it's moving, okay, but it's actually stationary. And an armature that moves, and with brushes, contacts, and two magnets. And what was cool about this is I knew from New Electromagnetism version 3 that this would generate a DC voltage. That's why I came up with it, because in my brain, New Electromagnetism version 3 explains this. Okay, but then classical theory using the B model, well, how does it explain this? The flux in each one of these ring areas stay the same. Okay, so how could it, and then the armature moves with the magnets, and according to classical theory, you need relative motion. Where New Electromagnetism says you don't need relative motion, parallel motion should work. Okay, so because of that, I developed this, and here is the, next page. This is the actual video from the era. You can see how crappy videos were. A Tamiya motor driver, crummy wood stuff with carbon grease all over the place, the old oscilloscope. But you can see I drove it in one direction, got a DC, and then I drove it in the opposite direction, got the same value. Okay, so I put this online. There was an uproar, a furor, but then later on a professor came up with an email which had a reasonably good classical explanation. And we'll get into that explanation in a moment. And I'm a reasonable guy, okay? I don't want to come up with something that's bullshit. I want the truth. And I don't mind people telling me I'm wrong, but a lot of times people tell me I'm wrong because they don't want me to be right and they can't come up with a reason why I'm wrong. This guy had a reasonable explanation, so I bought into that explanation, okay? But it turns out this was a missed opportunity, and I'll explain that in a moment, in a later when we talk about the Paradox 3, which is next. So late in 2019, I was working on a lot of other stuff, and all of a sudden, out of the blue, an idea for a third version of Paradox 3, I call it, which would defeat the professor's argument. Okay, in the Paradox 3, because what the professor's argument was, with right here where the magnets were from Paradox 2, because the wire isn't perfectly thin, is there could be a energy being developed because of the flux moving relative to the thickness of the wire. And that was a valid argument. That's why I didn't. And the back of the napkin calculation gave me something like 100 micro, not as much as I was seeing, but then I'm like, okay, well, maybe my measurement was off and blah, 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 blah. So I came up with this one because you have equal and opposite magnets over the brush interface, the flux at this point in the wire is 0 according to classical theory, and that defeats the professor's argument. Okay, and let me go to the uncut demo. And this is the demo that I did after, but here's the Paradox 3. What I have here, it may be hard to see in your video, there's a RF nano with a microvolt instrument, a battery, and this transmits the microvolt measurements to the computer under the table, and it gets displayed like an oscilloscope up here. Okay, the reason why I did that is because a lot of times people say, well, it's the closing path that couples, blah, 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 and I wanted to defeat that argument too. So here is the 2019 demonstration. Okay, and the average is 150 microvolts. Now we're going to switch the direction to make sure this is not a affect, and it is also like minus 160. Let's say 160. Okay, so after I did that experiment, I went out to go back into physics to simulate to see what results I got. And what blew me away is New Electromagnetism version 3 could not explain this. Okay, I was dumbfounded. Okay, and so what I did is I went back, and my Patreon folks have seen this experiment. And if you want to go to the Paradox test set, there's a video thing. I've got the link in the low bar for a video series on the building the Paradox test set. The Paradox test set I've designed with multiple different armatures that can be put in to do all the different experiments. So I only have to build one test set, and it's more precisionally built. What you saw in the previous video was the Paradox 3. That was my first attempt at 3D printing things, and it wasn't as good as it could be. So I realized from that first build of using a 3D printer is good at certain things, not good at other things. So I built the Paradox test set to improve the measurements of all of the experiments we're doing. And the PDX test set can do the Paradox 2, 3, 4, as well as the wire experiments, which we're going to talk about coming up. So this was the 3D printed parts. These hold the magnets, and this is the brush assembly. And when I ran this, and I have the data's online, my Patreon folks are aware of the data, I still could not get this to reconcile with new Electromagnetism version 3 either. And that was great because it means this was the open door to the rabbit hole, but I did not know that 15 years ago because I assumed that my theories explained it. I didn't do the due diligence, but I couldn't because I did not have the ability to measure it as precisely as I can today. I had no speed control on the thing because I didn't understand. Wasn't familiar with stepper motors at the time, and I did not have the confidence in my theories until after 2007 when I did my graduate thesis and I was able to nail the induction of inductors. So I realized I was on the right track. Okay, I was not the rabbit hole warrior then that I am today. So I probably would have jumped down that rabbit hole then if I'd gotten it, and I probably would have floundered because also my master's degree gave me a lot of skills I did not have back then that have improved my ability to do numerical analysis and mathematics and all the other stuff. So, and not only that, in 2004, I was preparing to go into my master's degree. My mom was sick with cancer. I was working full-time. It probably wasn't the best time for me to jump down a rabbit hole at the same time all that other stuff was going on. So that's why I put the PDX2 on, and it was probably a better decision, probably a better thing that happened. So anyway, so we have the invasion of Wonderland afoot, and it's from December 2020. I stopped all the work in Ethereal Mechanics temporarily, of course. I've been working like crazy to reconcile the physics result with experiments going nowhere. Going nowhere. So in the summer of 2021, I realized that there may be more than one unknown that is making this too complex to rationalize. So I need to divide and conquer. In other words, I need to simplify the experiments into smaller pieces so that I can uncover each of the effects separately. And it's like what you do if you have a prison riot and you have thousands of prisoners rioting and you only have a handful of guards. What do? You close all the doors to separate the prisoners into smaller areas that can be what they call in the military defeated in context or defeated in detail, whatever. You get the idea. Divide and conquer. So I came up with the PDX wire experiments, which I'm using the PDX test set on, and we developed the 3D printed armatures and 3D printed stators. Okay, and by eliminating the moving armature here, I eliminate one of the unknowns. And so this is called the D experiment. We're using the PDX2. Now, this is in Paradox 2. This is the magnet configuration of the Paradox 2, but this is not the Paradox 2. This is called the PDX2 wire experiment. This is not really Paradox 2. This means it is using the Paradox 2 magnet configuration, but this is the wire experiment. And so all the wire is stationary here in all of the three different configurations. This is the phi configuration. So by measuring all three of these, we can decompose how the moving magnet intersects different configurations of copper. Okay, and we're doing that with the PDX3 magnet configuration with all three wire structures and the PDX4 as well. Now it's interesting because this guy, I just threw this in because it was easy enough to add the third orientation of the magnet. Because with these three orientations of the magnet, we have covered all the possible bases of what could be going on. I added this in only because it was easy enough to do and we should cover all the bases. It turns out that the PDX4 is the actual showstopper. It is the most amazing decision I think I've ever made, because I would have never in my life, if I had limited time and limited resources and I had to eliminate one of these experiments, I would have eliminated this one. Okay, I did not know that this was, I would have never have thought that moving a magnet orthogonal to a coil like this would in any way be anything interesting. This has turned out to be the most amazing thing, one of the most amazing things. You'll see. So here is the PDX wire armature, which can hold the magnet in each one of the 3 configurations: paradox 2 configuration, paradox 3, paradox 4. This is the wire structure. Four of these were made, and so what we do is we place a wire in the track with glue or contact cement in each of the 3 different, and then we can swap out this stator. If I called it an armature, I mean it's a stator, and we can swap this out for each one of the different experiments, and then we just move the magnet from slot to slot to take all the different magnet configuration measurements. Now you'll notice we have a little areas where things don't fit. That's because we have about 45 microvolts of ripple, and we'll get into the ripple in a few moments. Okay, but this is the paradox 2 magnet configuration, the wire, the D form of the wire, and this is the inverse data. The simulation is inverse, but the data is forward. And like I said, because we assume that whether you move the magnets or you move the wire, it shouldn't matter. You should get the same results, and this is showing that to be true. Okay, and this is the paradox 3 magnet configuration, the D wire structure, and the inverse simulation. And there's the 4DI. Now here's an interesting thing, and we're going to go research this later on. Our ripple, there's our 45 microvolts of ripple right there. Okay, you don't see it on this. You only see it here. You can see noise here. You can see the ripple here. This is where the magnet is actually over the wire of the D. Here, this is where the magnet's over the backside where there is no wire loop of the D. And this shows that we have coupling from the magnet to the wire. That's the only thing it could be. So this shows there's something, very small effect that we're going to take a look at later. I'm pretty sure this is due to the vibration of the experiment, but I'd like to understand how that vibration correlates to this ripple. And then we have the 4O. And here's our ripple magnified, because this is our 45 microvolts. There's 45 microvolts of ripple. And it shows all of our theories say that there should be no voltage generated in the loops, in an open loop. This is a loop, an O. This is the O configuration. I should have put a symbol here to make it easier to understand what the shape of the loop is. Okay, so now we're filling out our punch list here. Again, we're using the data from the 2D experiment, the 3D experiment, 4D experiment for the inverse. Everybody gives good results. We were still looking at, this is where variant C was thrown out. We still compute it for other things going forward, but just to see what it does. Variant D and E aren't shown here because they were thrown out much earlier, because in fact we're filling out this punch list from earliest to latest, but the experiments that I did for the 2D threw these out. Well, you'll see it. The data is here because we did this data last. So now this is the regular 2D, and everything looks the same. But this is where things start breaking down. Again, remember what I said. This is a case where the magnet's in motion. And like I showed you before, there's an issue with classical theory in magnetism with the magnet in motion. And because New Electromagnetism version 3 magnetism is kind of a derivative of classical theory, it should also be suffering too. Okay, New Electromagnetism V5 is a completely new thing, derived from a more fundamental model, and we'll talk about that later. But you can see here classical theory is rising. New Electromagnetism V3 is degrading, but V5 is holding the line. And here's where I said the 4D is just the showstopper.
This is really amazing.
4D is getting the exact, the version 5 is right on the money, and classical and version 3 are diverging here. This is the showstopper. Again, now we're going to the 4 with the plain old open loop, and because there's no flux change in the loop, there should be no voltage developed in the loop. And we're seeing the opposite is happening, that the version 3 and classical are predicting a voltage. Now, for you apostles of classical theory, You should rightly be saying, well, wait a minute. How does the flux inside the loop couple to the loop when the flux is never changing inside the loop? And I'll tell you, that's Faraday's law. That's not F equals QV cross B. But you can get classical theory to give you a zero answer. Okay, because instead of doing what I did is make the flux emanated by a fragment follow the fragment of wire, is what we did. Because then your fragments are all moving at different velocities, and then you should be coupling to the loop if that were true. But if you now said that, well, the magnetic field follows the magnet like Einstein, not just follows the wire, but follows the magnet, then you have to pick a point on the magnet, like the center of the magnet, from which all flux lines must emanate and be correlated to. Okay, that will give you a zero answer with classical theory here. But unfortunately, it violates locality. Because how could the center of the magnet have anything to do with the edges of the magnet? Now, if you want to go down that road, you can. I don't care. I've got a version here that completely takes care of the charges are the source of the magnetic field, and it takes care of that problem. We don't have that problem. So if you want to go down that road with classical theory, go right ahead, knock yourself out. But as we go further, that won't save you for the later experiments coming up. So now we're filling out our punch list. Okay, the 2D experiments, everybody agreed. And this is where variance D and E were thrown out, because I did these experiments first. These were the first ones run for new electromagnetism V5. And so this is where D and E were thrown out. Okay, but I put them here I shouldn't even bother to put them there, but because they're kind of irrelevant, but just to be complete. Okay, so that's where we are right now. The next step is we have to go to the paradox single magnet experiments. Okay, again, like I said, we're moving step by step, baby steps back to the paradox experiments. And basically it's the same idea as the paradox 2 here, except we're going to use a single magnet. And that's the same with the 3 and the 4. So the new Fusion 360 models, I have an armature, which has slots to accept magnet holders. I already have these parts built, and we're going to have the experimental data out, hopefully, before the end of this year, which is 2021. So a wrap up of where we are. We have to rerun the force experiments, and we have the paradox 2. This 1 means the one magnet experiment to distinguish it from the normal paradox 2, paradox 3, paradox 4. Once we get these, then we go back into the 2, 3, and 4 and see if we can't get, now that we have the new models, new electromagnetism V5, because new electromagnetism V5 came about because of this, because I couldn't get any correlation with the 2D, 3, and 4. That's why all this was done here. This is where the first experiments done. This is where new electromagnetism V5 was born. And it was a happy accident, because when I tried it, I just happened to have a variant in there that was a mistake, and my Patreon folks are aware of that. So it was a happy accident, because the variant A was the happy accident, and that got me to variant B. And then after I got there, I said, well, we can also infer C, D, and E. And I knew C, D, and E weren't going to work, but it's good to throw stuff out there just to try it, especially since the software is doing all the work, doing all the simulation, and I just plot the data and say, it failed or didn't work or whatever. Okay, so for my YouTube crowd, this will be the last public release of anything related to NE version 5 until the paper is made public. Okay, passenger tiers and above will be able to see the progress as it happens, and they've already seen things that have not been released. So once, like I said, in the previous page, a couple pages back, everything will be made public, but my Patreon folks are going to have first crack at everything. So please help. Consider becoming a patron. Okay, $5 a month to watch real progress being made toward a unified field theory, in my opinion, is a bargain. Okay, I mean, it's cheaper than your favorite porn site. Come on. Okay, mainstream science has been stuck for over 100 years. Okay, relativity, general relativity came out in 1916, and quantum mechanics was founded somewhere in the 1920s. Relativity has a model of gravity, but it doesn't have a model of matter. Matter is just a ubiquitous number you pump into the relativity equations. There's no model of matter there. Quantum mechanics / standard model predicts have a model of gravity, but they can't figure out a model of matter, but they can't explain where gravity comes from or how matter reacts to gravity. Ethereal mechanics, I have both a model of matter, you've seen it at the beginning, and a model of gravity. And it's unified through an improved model of a dynamic ether. Okay, and there's so much work to be done. I need help to be able to do this full time and to be able to hire people to help. If I can offload making of the videos and the writing, and I'm not good at that, only because I want to do the science. If my only job was making videos, I'd be pumping all kinds of flashbang graphics and whiz-bang stuff to make these videos better, but I want to do the science. I don't want to spend time doing videos, but I know the videos need a better quality. Okay, and I'll show you that science is frozen because you have a leading researcher called Mikio Keiku. Oh, sorry, I forgot the H in his name. And he's writing books of fiction. Parallel worlds, physics of the future. He's talking about physics of the future, but he's not making any physics of the future. And if you go to Brian Greene, who's the quantum mechanics side, he too is, quantum mechanics is more strange than we can possibly imagine. Oh, yeah, okay, so we're getting nowhere. Because these guys would rather pump out books for rubes than actually do the work. Okay, I'm an engineer. I can't do my work if these guys are producing fiction. So I'm doing their job because I can't do my job because I don't have any valid models. And here's your stick. Before what I told you, that's your carrot. This is your stick. Our survival depends upon a unified field theory, not talk, not BS, and not appearing on episodes of The Simpsons or Big Bang Theory. Okay, I have a video out there called our trailer video 3, which says that UN Sustainable Development requires a 90% population reduction. I came out with this video before the UN published their numbers. And my number said that 90% population reduction would be a very safe, with lots of margin for any disasters for the human race. And I said 80% was my first number, and I said that is our bare minimum, that 80% population. And what sustainable development means is once all the oil is gone, and once all the coal is gone, once all the natural resources have been dug out of the ground, how does the human race sustain its population on the earth? That's where we have to get to be a sustainable race on the planet. Okay, or now, after I published my answers, 3 months later, they came out with 75%. Okay, now this was all done long before the pandemic, long before that. This was a couple years, 4 or 5 years ago. So how do you reduce the population of the earth? Well, there's only 2 possible solutions I could come up with. Some kind of purge, okay, whether that be viral or just getting everybody angry with each other so everybody wants to kill each other. I don't know. But the distinct solution is we have to build starships. And we're not going to be putting people into space on the back of Roman candles, no matter how much I like Elon Musk. That is not a viable solution. I don't think we have enough oil in the ground to supply the rocket ships necessary to get us to other worlds, or to even build ships such as this. So we have to come up with something, because according to Ethereal Mechanics, every cubic meter of empty space contains $17 trillion worth of energy. There's plenty of energy all around us. And that was actually Arthur C. Clarke's argument in 2001, A Space Odyssey. The solution to the human race is all around them, and they can never see it. In the beginning with the monkeys were dying of starvation without realizing food was all around them. And it was the monoliths that came down as teachers to teach the monkeys. Great. Read the book. The movie doesn't make any sense, but if you read the book is actually quite good. Okay, then I have my trailer video T1, which says, okay, assuming we do move out into space, okay, The distance between habitable worlds is very vast, and the only way that we're going to survive, because if we can't put all our eggs in one basket, and it can't be like Jennifer Lawrence in the movie Passengers, where it took 200 or 120 years to get from Earth to a habitable world. We're not going to be able to survive like that. If you have a natural disaster on one world and another world can come to its aid, no one on that other world is going to spend 120 years coming to your aid. And if you have a natural disaster, you can't last 120 years. So I did a reasonable argument in this video that unless the travel between worlds is less than 2 months, that will be practical. Anything beyond that starts becoming impractical. And in order to achieve that, we need at least 500 times the speed of light. Because if we don't achieve that, then we are basically all on this world, and we are one plague, one atomic war, one asteroid impact, one sun going supernova away from complete extinction. Okay, so I need help. I want to be able to do this full time. Okay, right now I am the number one person funding this. My Patreon folks are help taking the edge off with their funding and their support, and they give me advice and information. It's great. Okay, if you want to be part of this, okay, etherealmechanics.com is my Patreon site. $5 a month, and you'll be a passenger to watch ourselves get to the stars. And I'm putting all my time into this, and I have 100% have devoted my time to this. And only today it's Christmas. I got to go spend time with family. I know for a little while. Then I'm going to get back to this. Okay, so my website is distinti.com. You'll find a lot of the papers there, a lot of the links to the videos here. It's better organized, but it still needs more work. I can hopefully get to improving it a little bit. And then we have our blog site, etherealmechanics.info.